Hi everyone, in this video we're going to be discussing segment theorems. Our first theorem is going to be about tangents. A tangent segments are drawn to a circle from an external point are congruent. So for example, in this diagram, DC and CB are congruent. They're both tangents. So in the example problem where we have AB is 15, that would also make CB 15 as well, because segments are congruent. Next, we have if two secants intersect outside the circle, the product of the measures of the secant and the external segment equal the product of the other secant and its external segment. So for example, I always refer to this as whole times exterior is equal to whole times exterior. So we have B, that represents the whole. A is the exterior. And that's equal to the whole again, which is D, I'm sorry. And C is the exterior. So let's look at our example. So here we want the whole. So the whole is 14 plus 10, which is going to give me 24. Make sure you add when the two segments are next to each other. So we're going to have my whole, which is 24, times my exterior, which is the 10, is equal to the whole, which is x, times the exterior, which is 8. So 240 is equal to 8x divided by 8 on both sides. 240 divided by 8 is 30. So that whole represents 30. So remember, when you have two secants, whole times exterior is equal to whole times exterior. Next, if a tangent and a secant are drawn to a circle from an external point, the square of the tangent segment equals the product of the secant and its external segment. So A represents our tangent. So the rule is we're going to square that, and that's going to be equal to the whole, which is C, times the exterior, which is B. So let's look at an example. Again, x is my tangent, so I'm going to square that. It's equal to my whole. Now remember, 8 and 4 are next to each other, so we're going to have to add them. So 8 plus 4 is 12. So that's going to be 12 times my exterior, which is 4. 12 times 4 is 48, is equal to x squared. Take the square root. So x is equal to the square root of 48. If we wanted to simplify that, that would be radical 16, which is the largest perfect square to go into 48, times 3. So that would really be 4 radical 3. Next, if two chords intersect in a circle, then the product of the measure of the segments of one chord equals the product of the segments of the other. So again, I have two chords. They intersect each other. A times B, they're on the same chord, is equal to C times D on the other chord. So this one I think is a much simpler concept. So all you have to do is multiply what's next to each other. So on one chord is 3 and x. So that's 3 times x. That's equal to the other chord, which is 6 times 4. 3x is equal to 24. Divide by 3, and you get 8. Again, you could always substitute back in and make sure it makes sense. 3 times 8 is 24. That's equal to 6 times 4, which is also 24.